everyone, and welcome to this video. This video is all about how you can use linear relationships and drawing straight line graphs, or any graphs really, to find rates. So as you can see there in those notes, when we're looking at rates from graphs, we are often looking at speed and looking at distance time graphs. However, we can also look at a couple of other different things such as temperature versus time and things like that that can help us in a variety of ways. Now, to make it a little bit easier to find this idea or to find the rate, we actually use the gradient. So for our purposes, we actually use the gradient for the rate. So we use the gradient being, all right, so m equals rise over run. Okay, so in our example down here, we've got our rise and we've got our run. So in this particular problem, our rate or our speed is still rise over run, and we do it exactly the same way as we would do for gradient. So I'm going to put in my rise of 100, my running of 2, and I'm going to get 50 kilometers per hour, and that is how we're going to find some rates today. What it is exactly is just a rate comparison to time. Alright, so we're just finding the rate as a comparison get the right button. Okay, so it could be something such as liters, kilograms, kilometers, meters, temperature, so degrees Celsius, etc., all to time. Okay, so how we're going to do that is the comparison to time is going to be equal to the change in the quantity over the change in time. And that is the same as our rise over run. So this bit here is our rise. That bit there is our run. Alright, so we're usually looking at speed, sometimes temperature, and a couple of other different things. We're using the gradient and we're using that on the linear parts of a distance time graph. Okay. We also need to remember, alright, that we must include the units. Okay, we must include those units, otherwise it's not going to make much sense. All right, let's dive in to an example or two. Here's our first example. We've got a four-wheel drive vehicle completing a journey which is described by the graph shown. For the first hour, find the total distance traveled. So here's our first hour. Let's just highlight that first hour. All right, and that first hour is everything in this yellow section. Okay, So it's this line here that we're looking at specifically for this part of the problem. The total distance travelled, well, that's this distance. So we've actually got a distance travelled of 100 kilometres. Okay, now that's over an hour. So our speed, okay, is just our distance over time. So that's 100 over 1, which is 100 kilometres per hour. And we can use the same formula as before to do this. How fast was the four-wheel drive travelling during the second section? So let's change our colour here. I'm going to choose a nice light purple, and I'm going to colour in my second hour. So there's my second hour. Alright, or it's really the third section, or the second section, isn't it really? There's the second section. Alright, this is actually an hour and a half. Okay, now it is a flat line, so if we remember back to doing some gradient work, we know that a flat line has a zero gradient. So the speed that the four-wheel drive was travelling during that second section is 0 kilometres per hour. And that's just straight up using gradient as our information. The final section, I'm going to use a little bit of a light pink colour. Alright, is this big section right here. Okay, this last section is about 2 hours long. Okay, and we've travelled all of 50 kilometres. Okay, that's a distance of 50 kilometres. So to work out our speed this time, or our rate, we're using our rise over run, which equals a rise of 50 and it's a run of 2. So that difference there is that 2 hours. So it's a run of 2, and that difference in the height is 50, so it's a rise of 50. Okay, and that means that our four-wheel drive was travelling at 25 kilometres per hour. So they've actually slowed right down in that last section. They've probably gone on the main road in that first hour, had a break before they got started, and then that last 2 hours they've spent in some pretty rough country. So this is the kind of story we can see from these graphs. Here's our second example. And this time we're dealing with a bit more of an environmental type thing. We're filling a container with some liquid, probably water, from a hose. All right. We want to know how many litres were filled during the first 10 seconds. So I'm going to keep using my pink. There's my first 10 seconds. Alright, I go up, I hit that line, I come across, and 5 litres is where we hit. Okay, what about the final 10 seconds? I'm going to use a different colour for that final 10 seconds. I'm going to go back to my little purple. This is the final 10 seconds. Okay, the distance there is going to come across, so we're going to have a starting point at 10 and an ending point at 20. That means we have a difference of 10 litres. Okay. Then we have how fast, or what was the rate that the container was being filled during that first 10 seconds. All right, so our rate for the first one, all right, is still our rise over run. Which is 5/10. Which means we're going to have a rate of 0.5 litres per second. You can see there how important it is to keep the units included. That final 10 seconds, what was the rate? Well, again, it's still rise over run. The run is still only 10 seconds, but this time the rate was 10 litres. So that's going to give us a whole 1 litre per second. And again, make sure you're including those units. Our final question is between the 20 and the 10-second marks. So we're looking for this last little bit in here, which is just another 5. So in that particular section, still using our rise over run idea, is back to being 5/10, which is 5 litres per second. Now, hopefully this has been helpful for you.